Hello everybody. Now today we are going to start a new topic of magnetism and magnetic effect of electric current. And so this is the first lesson which will focus on the introduction part in this particular topic. And as you all see, it is written there, magnetic field, Oersted experiment and magnetic force. So learning objectives are the knowledge and understanding about magnetic field and force, and we will also try to understand the equation of magnetic force, which has a special name, and then we will also able to understand how electric field and magnetic fields are related, or electric energy and magnetic energy are related. So the work for today is not much, but we will have to start in this unit with these concepts. So let us now magnetic fields, it has been observed by many scientists and especially by Oersted that it was created magnetic field, the conception of or the generation of magnetic field is due to electric current. And so later on many more scientists and Faraday and Lorentz and lenses, all these people came into the study of magnetism and electricity and the interrelationship between these. Macroscopically, if we observe in a bigger way, larger manner, macroscopically, if we try to observe, then we find that electric current generates magnetic field. Now we have to understand that magnetic field is another force experienced by magnetic poles of small objects which are known as magnetic materials. That means this is something extra, some extra force which we observe apart from the gravitational force and the electric force. So macroscopically, in a bigger way, it has been found that electric current, if it is flowing through any conductor, then it generates magnetic field around it. Magnets get influenced around a wire which has electric current passing through it. So this is in a macroscopic manner, bigger manner. But if we go into the microscopic details, we will find, and it is a lot of studies has been done on this. Microscopically, atoms are responsible. It is very interesting that atoms are responsible for magnetism. Atoms are responsible for magnetism. This is then an atomic property. It is an atomic property. Now, if we separate electrons and protons from an atom, then the very existence of atom is gone, and then the magnetic property is also lost. Then there is no magnetism. That means atoms are smallest magnets. And the bigger magnets can be molecules, and then bigger molecules, and then collectively crystals, or rather big pieces of matter, and so on. And we know in our childhood we used to play with small magnetite materials which we used to pick up from here and there, and they used to attract small pieces of iron. Those are some of the oxides of iron which also show a lot of magnetic property. So this is how the basic concept starts, that macroscopically electric currents produce magnetic field, and microscopically small atoms are responsible for magnetism. Now there are large number of things which show magnetic property. For example, we can show that if there is a wire, this is a straight wire which has current, electric current passing through it, then around this wire there will be a magnetic field all around the wire. It is not at a small place. Everywhere there will be magnetism, and it is very interesting that magnetic field surrounds the wire. So this is the magnetic field. So current carrying conductor, this conductor is carrying current, suppose I. So current carrying conductors create magnetic field. So this is one thing. Then there are loops also. Every time it is not always possible, or rather true, that we will have only straight conductors. Loops are also there. For example, like this. This is a loop, and this loop also has current passing through it, suppose. Now there is magnetic field like this, and magnetic field lines are similar in shape to the electric field lines. They have similar properties, but they are not exactly same, but they are similar. So this is the magnetic field. Like this. So magnetic field is produced by current carrying loops. Current carrying loops. Now these are the two macroscopic views of generation of magnetic field. Now you all know that there are magnets as well. There are magnets, small pieces of magnets, and if the magnet is in this form of a small bar, we call it as a bar magnet. And you know that one side is north, the other side is south. So this is a bar magnet. And bar magnet also produce magnetic field. Then there is the earth itself. Earth itself is a huge magnet, you know it. And this is, suppose the earth, and earth has a magnet, and it has got a magnetic axis. And it is also very interesting to know that in the geographical north of earth there is the south pole of the earth's magnet, and vice versa. And one more very interesting aspect of understanding in the earth's magnetic field is that it extends to a very, very large distance in space. And lot of solar flares, you must have heard about solar flares, solar energy at times disturbs the earth's magnetic field. And so there is lot of energy flow around earth which can disturb the atmosphere and thereby the living organisms also. So all these indicate that there is a presence of magnetic field. And who is going to experience a magnetic field? Magnetic force is experienced by small magnets or magnetic materials. And I hope that all of you know that what are the magnetic materials. from our childhood we know that anything which has essentially iron in it is magnetic. Similarly, there are many other metals which show magnetic material, even alloys like steel, nickel is another element, cobalt is another element. And for you to understand very clearly now and to remove all the misconceptions, every piece of matter has magnetism in it. Now you will say, what is this? Is wood magnetic? Wood is magnetic in that sense, but the magnetic property is so less that it is not realized or it is not observed in daily life. Because as I told you, you can go back to this concept that atoms are the smallest magnets. So wood is also made up of atoms. So magnetic property is there, but the magnetic property is not highly pronounced. It is not highly effective, and that is why wood is not a magnet, or it cannot be changed into a magnetic material. But there are substances, all substances which are magnetic can be categorized into different parts or different categories. Some magnetic substances show lot of magnetic property and they are called magnetic substances. Some show very, very less or feeble magnetism, and that is why they are called non-magnetic substances. And one more interesting thing is matter is magnetic. Remember this. And so gas and liquids also show magnetic property. So it is not that magnetism will be only shown by solid substances. No, it is not true. Magnetism can be shown by gases and by liquid material as well. So I think you must have understood this concept of magnetic field. Let us understand what is the SI unit. The SI unit of magnetic field is named after Nikola Tesla, who was one of the, again, scientists and physicists who studied a lot of magnetism, and so the name goes Tesla. This is the SI unit, and there is one more unit which I want to mention here, and that is Gauss. Do you recall this name? This name appeared in the Gauss's theorem in the chapter of electrostatics. And Gauss also studied magnetism and electricity because, as I told you earlier, that there is an interrelationship. So Gauss is another unit, but Gauss is smaller unit. It is a smaller unit. And Tesla is a bigger unit, and 1 Tesla is equal to 10,000 Gauss. So this is one of the conversion formulas which will be important for you, because at the time of solving numericals, these interconversion formulas become very important. So this is about the magnetic field, and let us understand the other aspect of magnetic field intensity. Now you know that magnetic field and electric field is measured by a quantity, and that quantity in the chapter of electrostatics you already learned that it is called the electric field intensity. Here we call magnetic field intensity. So magnetic field intensity at times is also defined in terms of flux. Do you recall electric flux? Electric flux was studied in electrostatics. Similarly, there is magnetic flux. Magnetic flux is nothing but the density of magnetic field lines passing through an area. And this is also a measure of magnetic field. And we call then magnetic flux density. So magnetic flux density and magnetic field intensity are similar in nature. And when we define magnetic field intensity in terms of flux, then there is another unit of magnetic field if it is defined by magnetic flux is Weber upon meter square. So this is another unit of SI unit. This is an SI unit. This is another unit of magnetic field intensity. So now we have, if you see, 3 units: Tesla, Gauss, and Weber per meter square. So this is something which you must understand. And now what we are going to do is we will try to understand one experiment which was done by Oersteds, and we are going to draw a circuit diagram to make you understand how Oersteds found out the relationship. So this is known as Oersted experiment, and the circuit diagram that I am going to draw here, you have to, it is a very simple circuit diagram. It is nothing special about it, but yes, it is very important for our own understanding. What he took one resistance, any wire which you all know act as resistance, and he connected an ammeter and a rheostat with the help of a key and a simple battery, and connected it. He also took one small magnetic compass, or which is also known as magnetic needle. So you all know what are these? This is the resistance, this is ammeter, this is rheostat, this is key, this is battery, and this is magnetic needle. What does magnetic needle do? Magnetic needle is nothing but a small magnet which will get deflected. It will move if there is a magnetic field at that point. So magnetic needles or magnetic compass is nothing but a detector. It is called a detector of a magnetic field. Now what Oersted did is he put on this switch. The moment this key or the switch is put on, he found that the magnetic needle deflected. It showed certain deflection. And then he put it off. When the key was put off, he saw that the needle came back to its original position. He kept repeating this, and he found that whenever current is flowing through the resistance or through this circuit, there is a generation of magnetic field around the wire, which was detected by the magnetic needle. So this was a very important experiment. What were the inferences? What were the inferences? Inference number 1, electric current generated magnetic field. This was the first and the most important understanding developed after this experiment. Number 2, strength of the electric current, strength or the amount of electric current, strength of electric current changed the intensity of the magnetic field. How this was noted? When the current was increased, there was more deflection of the needle. When the current was decreased, there was less deflection in the magnetic needle. So it was directly observed that strength of the electric current changed the intensity of the field. And the third one is changing the direction of current changed the direction of magnetic field. So if the polarity of the battery is reversed, the negative is now at the place of positive, and if the current is changed, the flow of the current is changed, then the magnetic needle got deflected in the opposite direction. So it indicated that the direction of the magnetic field has changed. So these were very important aspects or understanding or inferences after this experiment, and it clearly established a relationship between electric current and magnetic energy. So both were related. Now this was something extremely important because earlier scientists thought that magnetic energy and electric energy, they are separated. They are not related. But now they have an experiment which told them very clearly that electric field and magnetic field are very much related to each other. And so what I am going to give you here is a website, or rather in YouTube, there is this see the experiment, Oersteds experiment, which we just discussed. See the experiment at http://www.youtube.com. I will also see it right now if the internet is working. For capital X N J U W. So if you can see this, it will be very interesting aspect of.
In 1820, the Danish chemist and physicist Hans Christian Oersted performed a celebrated experiment demonstrating that an electric current passing through a wire could deflect a magnetic needle. The experiment can be reproduced by means of the following apparatus. A wooden base carries a magnetic compass. A brass frame above the compass holds a thick copper wire with a small clip at each end. A pinion is used to raise and lower the wire above the compass needle to determine the relationship between its deflection and its distance from the wire, through which an electric current flows. 3 leveling screws ensure that the system is perfectly horizontal. After arranging the device so that the magnetic needle is parallel to the conducting wire, the two ends of the wire are connected to the electrodes of an array of batteries, and a current is sent through it. We observe that the needle deflects towards a position at a right angle to the direction of the wire. When the direction of the current flow is reversed, the needle still tends to deflect toward a perpendicular position relative to the wire, but this time its poles are reversed from the previous position. In a similar experiment, Oersted demonstrated that a continuous electrical current flowing through a conductor generates a magnetic field. He was thus the first to prove the interdependence of electricity and magnetism.
Right. So I think this is extremely important for you to. You can always see this again later on for your better understanding. But there are many other YouTube videos which are also interesting. Now the next teaching topic which I have kept for today is the magnetic force. So I will take it up here as magnetic force. Now magnetic force is also called Lorentz force because it is an extension to the total electric and magnetic force. At times it is called, but later on it was realized that Lorentz force is not just the magnetic force, it is then after named as the total electromagnetic force. I will recall a little bit of the electric force. We say that electric force is equal to charge times electric field intensity. Magnetic force is found out to be V, Q and V. I would like to define what is V. V is velocity of charged particle. Q is the charge itself, and B is magnetic field intensity. Now, this equation will tell you very interesting aspects of magnetic force. This is called FB. B is the letter which is used for magnetic field. Very strangely, it should have been by M, but interestingly it is written by B. Now magnetic field or magnetic force is dependent on velocity, direct proportionality, charge and magnetic field intensity. So if magnetic force is to be experienced by a charged particle, then it has to move. It cannot be stationary. Whereas this is not true for electric field intensity. If a charged particle is not moving, it is stationary in an electric field, then it will still experience electric field. But to experience magnetic force, a charged particle has to move. It should have a non-zero velocity, because if the velocity is 0, FB will be 0. So this is a very interesting and distinctly different property than electric field intensity. From here, the magnetic field value, if we try to find out, it is equal to F over V into Q. Now then, what is the SI unit? What is the SI unit from this? We have already discussed as units of magnetic field, but now we are trying to find out magnetic field intensity unit with the help of this new equation which has been just told to you. So this is Newton divided by velocity is meter per second and unit of charge is coulomb. Right? Now it is denoted by and the definition of the magnetic field is actually given from here. No other equation is used to define magnetic field. this is the equation which is used for defining magnetic field. How do we define? This is called 1 Tesla. So SI units are all equal. It is not that they are unequal. 1 Newton divided by meter per second into coulomb is called 1 Tesla. So how do we define? B is equal to F, that is magnetic field intensity or magnetic field will be equal to that force which arises if V is equal to 1 meter per second and Q is equal to 1 coulomb. So if 1 coulomb charge is moving at a speed of 1 meter per second in a magnetic field, then whatever is the force experienced by it, that is numerically equal to the magnetic field intensity. And this is what we are going to write down here for your understanding. So 1 Tesla magnetic field intensity is numerically equal to the force on a unit charge moving at unit velocity. And since all units are in SI, so it has to be 1 meter per second and 1 coulomb. So 1 Tesla magnetic field intensity is equal, numerically equal to the force on a unit charge moving at unit velocity. So for moving charges, there will be an experience of force in the magnetic field. The concept of magnetic field is generated by moving charges. For stationary charges, magnetic field is not generated. Let us go back to the smallest magnet. Inside a smallest magnet, do you think there are moving charges? Yes, there is one charge which is constantly moving, and that is electron. And when electrons move in orbit, it produces electric current in the orbit. Due to that electric current, magnetic property is generated. So until and unless a magnetic a charge moves, there will be no generation of magnetic field. And if there is a magnetic field in a certain region, then moving charges will experience a force. So magnetic property is actually related to the moving charges. Electric properties are related to stationary charges as well as moving charges. So now, if I want to make you understand very clearly that electric field and magnetic field are actually closely related and they are the causes of each other. If there is an electric field, there will be a magnetic field due to that, and vice versa. So this is a very interesting aspect of our learning today, that we understood three main points: magnetic field, the generation of magnetic field, Oersted experiment, how he was able to relate with the help of electric current, and how do we define magnetic field intensity in the context of magnetic force. Now I also talked about Lorentz force. Lorentz force is the total force, QE plus QVB. This total force is called electromagnetic force, and this is known as the Lorentz force. Lorentz force is the sum of electric force and magnetic force. So I think today's lesson was quite interesting. I would like you to research a little bit, do some more study on this topic, and come back rich with your knowledge. Thank you.